Hello. We are now working on solving nonlinear systems algebraically. We will walk through the steps to do this in words you see to the left, and then start with an example and work through more examples of different types afterwards. The steps to solve a nonlinear system algebraically would be to pick one of the two equations and either solve for x or y. This means that you should be isolating x or y so that one of those two letters is by itself on one side of the equation with no coefficient attached to it. You will then substitute that equation into the unused equation and solve for the remaining variable. And that would be the variable you did not solve for in number 1, x or y. And then you are looking for your second answer by substituting back into the other equations, and then check to see if you did it correctly at the very end. In different equations, there will be easier and harder ways to do this, but there are many different options, and that's one of the reasons solving systems algebraically can be challenging for students and learners of all ages. For this first example, we see one equation is x squared plus y equals 5, and one is x plus y equals 1. So what I am going to do is solve this first equation for y by just subtracting x squared from both sides. So that would mean that I would have y is equal to 5 minus x squared. So that means that I've done step one. I've solved for y. And now I'm going to substitute it into the second equation. So where you see this y right here, I'm going to put in 5 minus x squared. And I'm going to write that in green right here. 5 minus x squared. And the rest of that equation is unchanged. So I would probably want to write in, and this is where colors can be handy, x plus 5 minus x squared, and then equal to 1. Now from here, I can just notice that, well, I have a quadratic equation. So I personally want to keep my x squared term positive. So I'm going to move all three of these terms to the right side of the equal sign, which means that I would have 0 is equal to x squared, and we are going to be a negative x, and then we have 1 minus this 5. So that means that I would have a negative 4. To solve this quadratic, we will use the quadratic formula, and the setup for that would be x would be equal to the negative b value plus or minus the square root of b squared minus 4 times a times c, and all of that is going to be divided by 2. To solve this equation for x, we would use the quadratic formula. Once you've completed that process, the two answers for x that you would get would be x is equal to 2.56, and x is also equal to negative 1.56. And what would be left is to use probably the second equation to see if we can take x in both these cases and find y. So it would just be 2.56 plus something equals 1, and then the same thing with this x. Once you've used that second equation, you would find that the y value for this first x value of 2.56 would end up as negative 1.56 for y, and then coincidentally for the second x value, if you put it into our second equation, would end up with 2.56. So you have our 2 points are just reversals of each other, which in this case is just a coincidence. And we have finished solving this problem. And all you would need to do to check the answer is like, well, if I do x squared, or 2.56 squared, plus negative 1.56 on my calculator, I can check to see if I have done it correctly. And negative 1.56, and it checks out, not including a little bit of a rounding error from our decimals that we have here. So that finishes up this example. So let's look at some more examples together now. Here in the first practice problem to the left, we have y equals x squared minus 2x plus 1, and y equals 3 minus x. This is a unique problem because both equations are already equal to y. So if they both equal y, that means they both equal the same number. And that means that we can set these two equations equal to each other. So I'm going to write my first equation on the left side of the equal sign, and my second equation on the right side of the equal sign. And I have an equation to solve now. So what I would want to do is subtract 3 and add x so that everything is on the left side of my equal sign. So that would mean I would have negative 1x, and I would have a minus 2 is now equal to 0. From here, I could do quadratic formula or try to factor this quadratic to get an answer. So let's try factoring this time. We're looking for two numbers that add up to negative 1 and multiply to negative 2. Well, that would be negative 2 and positive 1. So then I would write it as that, x minus 2. And I would have x plus 1 is equal to 0. That means that I have one answer that is x is equal to 2, and one answer that is x is equal to negative 1. So if I use the second equation, all I have to do is 3 minus my two answers, and I have y values. So I would do over on the left side here, 3 minus 2 equals 1. And that would be equal to my y value of my first point, 2 comma 1. And then over here, I would do 3 minus negative 1, which equals 4. And that is my y value over here, which means I have my two answers. One answer being this system is intersecting at 2 comma 1, and the other would be intersecting at negative 1 comma 4. And both of these points would work. I can put them into the first equation or the second, and they would turn out to be correct. In example number 2, we'll be solving for x and y again, and I'm going to choose to look at this first equation and solve for the y variable. That means that I will have y is equal to 2x minus 3. This y value and this 2x minus 3 are going to go into this y right here. So I'm going to write the 2x minus 3 right underneath it. And you put it in parentheses. And then the rest of that equation will remain unchanged. So I would still have x squared plus the 2x minus 3 I put in, all equal to 5x plus 1. And now I'm just going to subtract the 5x and plus 1 and put that onto the left side. So that means that I would have an x squared minus 3x. I'm subtracting the 5x from this 2x. And then minus 4 equal to 0. Now, this is a pretty straightforward problem to factor, but you definitely can use quadratic formula. So let's just factor it really quick. The two numbers that add up to -3 and multiply to -4 are going to be -4 and +1. So I have x minus 4 as my first factor and x plus 1 as my second factor equal to 0, which means my one answer is x is equal to 4, and my other answer is x is equal to -1. And I'm going to use my original equation here, y equals 2x minus 3, to solve each of these for y. So I would have 2 times 4 minus 3 would be the same thing as 2x, or 2 times 4 minus 3 is equal to 5. And then on the right, for our second x value, I will do 2 times -1 minus 3 is going to be equal to -2 minus 3, and that gives me a -5. So this point where the system intersects is -1 and -5. And on the left side, I would have 4, 5. Now that finally brings us to our last equation, number 3. And we have an exponential equation and then just an x equals 4. So x equals 4 would be a vertical line, and so we're only going to have this exponential equation cross a vertical line one time. So all we really need to do is take this x, since it's already solved for, and put that into the x in the first equation. So this right here is going to go where this x is up at the top there. So that would look like 3 to the 4th power minus 5. And 3 to the 4th power is going to be equal to 81. So if we subtract 5 from that, we find that the answer is 76. And that means that the answer for this system is that the two equations would cross at 4, 76. And that concludes a quick overview of solving nonlinear systems algebraically. A reminder for this topic is that in many instances, it is okay to use whatever method you feel the most comfortable with. And you'll be able to, if you are asked to do it algebraically, you might be able to do it graphically instead. If you're asked to do solve a system graphically, it's very likely that it would be okay to do it algebraically instead. The most important thing would be to have a firm way of doing and solving these systems and reliably get the correct answer. Thank you for watching.